All right, so now we got area of a circle knocked out. Let's get to the real deal. So area of a sector. Right now we're going to try and calculate the area of sector ABC. So we have the book method and we have Baker's method. The reason I like Baker's method better is because it's just like the arc length formula. And to prove a point, this was arc length. This is now our sector equation. So we're using this formula right here, which says the area of the sector over the area of the circle equals the amount of degrees they give you over the amount of degrees total. So this is my measurement side, and this is my degrees side. So let's try it out. We're trying to calculate the area of sector ABC. That is highlighted in blue. What is the area of that sector?
4 pi.
I don't know. What do you call I don't know in math? X. What is the area of the sector? I don't know, aka X. Now, what is the area of the circle? Pi r squared. You can do that all in one step if you'd like. I'm going to write it out all the way. Now, how many degrees describe that sector?
60.
Over how many degrees in a circle?
360.
So, in this scenario, here's where I start to simplify. You might have already done this in your head. Pi 2 squared is the same thing as 4 pi. Now, instead of writing 60 over 360, I'm going to simplify that in my mind. 1 over 6. That makes my cross multiplication just a little bit easier. 1 times 4 pi. X times 6. And then divide both sides by 6. So we can simplify this fraction into 2 pi over 3. Still haven't really answered the question.
Units squared.
So the real answer is 2 pi over 3 units squared, because it is an area. Was it really that bad?
No.
No, it's just like arc length, but we're finding the area. Not bad. Not bad. Yeah. Maybe. Just talking to myself. All right. A little bit out of order. Find the area of a circle with a radius of 5. So it says, find the area of a circle. Just find the area of these circles. I don't know where sector came from, but.
So the circle has a radius of 5.
Yeah, so we have a circle with a radius of 5. How do you find the area of that?
Units squared.
Right? Not terrible. Cool? Well, here's where you guys get broke. Find the area of a circle that has a circumference of 18 pi centimeters. You do go backwards. Okay, so how do you find the circumference? 2 pi r. So the circumference is equal to 18 pi. Now there's 2 different equations to find circumference. I would prefer to use pi times d equals circumference. So these 2 things are equivalent. This is the equation for circumference. This is the circumference, but they are both circumferences. So in this scenario, the pi's cancel each other out. And what is your diameter?
18.
Now you can justify that your radius is 9. All right, so we've backward solved, and now the radius of that circle is 9 centimeters. Now you have to go forward and find the area of that circle. centimeters squared. They're a little out of order, but still, it's a good question. Yeah? Yeah? No?
How do you go from circumference to pi diameter?
Because one of the equations for circumference was either 2 pi r or pi d.
Oh,
I used pi d because it was easier for me to understand. But you can still use 2 pi r. Okay. Man. Find the area of sector RST in circle S, the diameter of 12, and the measurement of arc RT is 45 degrees. This is you guys applying academic vocabulary. So you gotta set up and draw your own picture.
So x over pi 6 squared equals 45 degrees over 360.
That's right. Can everybody else do that with no picture?
yeah.
So you're right, but can we draw a picture together?
Yeah.
Okay, so what would you start with when you draw your picture?
A circle.
Yes.
A sector.
Nope, nope, nope,
A diameter.
nope,
It's like cutting out.
nope, nope.
What she said.
Huh?
Sector.
The center of the circle?
Now cutting out.
Nope.
Circle.
Make the radius.
Name the circle. S.
Oh,
Alright. Now you can go a couple different ways.
okay. Cut in half.
Cut it in half, we'll call that the diameter. And the diameter is 12. I'm going to put that down here so it doesn't confuse anybody.
Now sector.
Now a sector.
So one line.
One line, you're going to connect your sector to your diameter.
Yes.
That would be the smart thing to do. What? Like that?
Yeah.
You could have done your own sector like that. It doesn't really matter. As long as you name your sector R, S, T. So now I know I'm describing this sector right here. I'll color it in. How many degrees is that sector? So this is what you're used to seeing. You're building the problem now, and some can do it in their mind. Some have to write it down. I had to write it down the first time. So what is the area of that blue sector? X. Because we don't know what it is.
I was gonna say I don't know, but
What is the area of the circle? Pi r squared. Because the diameter is 12, we have to cut it in half. You get pi 6 squared equals 45 degrees over 360 degrees. So we can do our simplification. All right, 45 over 360 simplifies down to 1 over 8. Cross multiply. Divide both by 8. What does that reduce down to?
9 pi.
No, yeah. Now, yeah. So shame on me. Here's a teacher mistake. I've made it very obvious that I want you to write units, right? Spoiler alert. For your quiz on Friday, it's 20 questions, but there are no units in the answer key. So there's an answer bank at the bottom of your quiz. So all the answers are already on your quiz. But there's no units. Is that going to upset you guys?
Yes.
Yeah, because
I will scream.
So here's your quiz,
Yeah.
and then here's all the answers at the bottom.
that's awesome.
Oh,
But there's no units. Is that going to make you mad? Okay. Well, then I can go through and add all the units.
No, I don't wanna put you to work.
Okay. Good talk. Okay.
Yes.
Are you ready? Are you having a good day?
Let's go.
What happened?
I mean, it's
Dude.
a swing.
What happened to that guy?
Wait, so like you have to find
You fell off the track.
You have to find the area of the crust of the pizza, not just the area of the whole pizza.
12.
Oh, I.
So yeah, I find the area.
Okay, let's do this pictogram here. So we already know how to find the area of it. We just learned how to find the area of a sector, right? Well, there is also a triangle inside of that sector. So I do the area of the sector minus the area of the triangle. It's going to equal the area of the wedge.
That makes sense.
So, just like third period, they're like, I can do sectors, no problem. And I was like, well, what's the area of the triangle? And it was just like, so let's get there. Let's do the easy part first. Step number 1, attempt to find the area of the whole sector. Find the area of this whole piece right here. The area of that sector is X undescribed.
Over pi 9 squared equals
120.
yeah,
Over
120 over
360.
360.
No.
That's where it comes from, right? That is setting up the formula. Now I'm going to go through my simplification process. X over 81 pies is equal to 1 over 3. So theoretically I'm looking for 1/3 of 81, but we can go ahead and do it. Broke a pencil. Divide both sides by 3.
27.
No. Pi.
Oh, I almost had it.
Well, you were like 50 away. Alright, so 27 pi units squared, which is the decimal like pretty close to 85. Alright, so any issues with finding the area of the sector? Okay. Can I clear off some space here? I'm just going to write the answer. Or I'll leave it. Now, here's where we're at. We've got to find the area of that triangle. Let me draw the triangle. There it is. Oh, we do know this. Yeah, right. Yes. Well done. Why is that also 9?
Because also
It's also the radius. Okay, so here's the first stumbling block. How do you find the area of a triangle?
No, it's times height times 1.
So the area of a triangle is 1/2 base times height. Do I have any of that information? No.
no.
Well, I mean, technically, yes, you do. Depends on which way you're orienting your triangle. Well, that triangle is all crooked on your paper, right?
Yeah.
So which one are you calling the base?
Both of them. Doesn't matter.
It does. It super matters.
So it does.
So if you're calling 9 your base, that means that your height is over here. That makes it kind of a right triangle. So your height is some undescribed length that you would have to calculate. Okay, I would not do that. Baker would do this. I would use this as the base and put my height right here. Most of you guys are more comfortable with that. Okay, so did that help you at all?
No.
So if this angle is 120 and you draw an altitude through that angle, that means that each angle is now 60 and 60.
It'll
Well,
be a 30 right triangle.
oh, it's a 30, 60, 90. I can do that. So now you have a 30, 60, 90 right triangle. It comes back to haunt you. Right? You always start across from the star. So this is your one side, your hypotenuse, and your square root of 3. So how do you get from here to here?
Divide by 2.
I'll let you do it right now for the sake of knowing. 4.5. And how do you get from here to here? I'll let you do it right now, even though it's not appropriate. 4.5 square root of 3. Okay? So, 4.5 square root of 3 is this length, and then CPCTC says how long is this length?
4.5 square root of 3.
So, if how long you add them together, right? 4.5 square root of 3 plus 4.5 square root of 3 is how many square roots of 3? 9 square roots of 3. So we have just stumbled upon the fact that our base is 9 square roots of 3.
So,
How tall is it? Times 4.5 times 1/2. So you just slam all that in your calculator and you get 1/2 times 9 square root of 3 times 4.5. I'll race you. I'm already losing.
Yeah.
35.
oh, so,
What?
what?
I didn't get outside my radical.
0.5.
Okay, I already lost. I have to rub it in.
Yeah. 35.
35. We'll just call it 35. Cool, 35?
No.
Okay. And that's it. That's our answer.
Oh, that's. No, I got it.
Easy.
That's it.
Is that it?
It's just a triangle. It's not-
Is that it? That was a lot of work to get one number. And then we had to do the area of the sector minus the area of the triangle to get the area of the shaded region. So 35 or 27 pi minus 35.
That's just the answer.
49.8.
49. 8, 2, 3, 6.
Crazy, right? And then I wish Tim was here to ask if he could use trig to solve for that. Yeah, hey, you can use trig to solve for that. You ready?
Would it be faster? All that?
I don't know, how fast is that? Okay, let's try it. What is the area of the sector?
27.
Okay, so let me get rid of this. So now I'm gonna redraw my triangle a little more friendly for us to understand that you guys are used to seeing. So because this length is 9 and this length is 9, that's an isosceles triangle, right? So how big is this angle? 30. We talked about that earlier. So because it's an obtuse triangle, you can drop an altitude, but it becomes outside the triangle, which is fine. We'll call this the height of my triangle. You know what? Screw it. Let me call it A, or A, and I'll call this one B. So if I use the sine of 30, the sine of 30 is equal to opposite over adjacent, or hypotenuse, sorry. Now, when there's a number on the bottom, you're allowed to move this number to the front. B sine 30 equals A. What? But what is A really? A is the height of the triangle. A is the height of the triangle. So if I was going to use the area of a triangle is equal to 1/2 the base times the height, it would be 1/2 times 9, right? Times B sine 30. Okay, but look at what is B? B is this side right here. So what I've just discovered is that I can use trig, and it's 1/2 the left side times the right side times sine of the angle between them. Okay, so if I use that for this problem, we've just verified that this equation works. 1/2 times one side times the other side times the sine of the angle between them. And if you remember back, like 10 seconds ago, we got the answer of 35, right? As the area of the triangle. 1/2 times one side times the other side times the sine of the angle in the middle. It works. But are you going to remember that? No. All right. Probably not. What, I should write it down somewhere? And this guy knows what he's doing. We'll get to that later. Let's try it one more time. Last one here. Last one. So, trying to find the area of this little bitty piece right here.
So x over pi 4 squared equals 60 over 36.
Most of you guys are super confident with that, hopefully. Now, because I'm trying to find the area of this shaded region, there's really no sense in like simplifying nasty fractions because I'm just going to end up subtracting them in the long run. So you get 16 pi equals 6x, divides both sides by 6. So we'll kind of leave that answer linger right there. We don't have to make it 8 pi over 3. The area of that sector is 16 pi over 6, which is some number. Okay, so I'm going to take 16 pi over 6. And I'm going to subtract the area of the triangle. I got to find the area of the triangle first. Now, don't freak out. I have a triangle that looks like this. And look, this angle is 60. So, how long is the radius?
4.
Well, how long is the radius?
4.
Now, that is also an isosceles triangle, which means base angles are equal. There's 120 degrees left. So it's also an equilateral triangle, just like on your quiz. Interesting.
That's dope.
So the base is 4, right? 60, 60, 60. So now I can draw and find the height. 90, 60, hey, 30. 1, hypot 2 noose, and the square root of 3. So to find the area of that triangle, it's 1/2 times the base times the height. Well, 1/2 times 4 is 2, and 2 times 2 is 4. So the area of the triangle is 4 square roots of 3. And the only way to figure out what that answer is to type it in the calculator and get a decimal answer. So 16 pi over 6 minus 4 square roots of 3. See how many times I can screw this up. 16 pi over 6 minus 4 square roots of 3. 1.45. That's it. And that's a really tiny number, but it's also a really tiny sector. So the answer is 1.45 units squared. Fun stuff, right? Yeah, we like it. Does it get any harder? Okay, so I'm going to give you a sneak peek at 2 of the questions that just dominated third period. And you're going to laugh. Shout out to third period watching this. You guys are dumb. Okay. Oh. find the area of the shaded region.
So you just gotta
Area
find
of the square minus the area of the circle.
This is literally the area of the square minus the area of the circle. And third period freaked out about that. What's the area of the square?
16.
Okay, nailed it. Good job, guys.
4 pi squared.
What's the area of the circle?
4 pi squared.
Wait,
No.
That's
so is the side length the same, like the diameter
Well,
of the circle?
pi is 2 squared, so 4 pi.
Which is like 16 minus 12, which is like 4-ish. Okay, the idea is there. It kind of makes sense? No. Because it's going to be A, B, C, D, E. Now, here's the other one that like dominated them. This one's a good one too. All right. This one's fun. Uh-oh.
Find the area of the shaded region.
So the radius would be
Literally the same thing.
It's literally
Find the area. Exact. It's just a different. The circle is literally.
no. So people don't see okay, 5. The area of the square is 100. Base times 5, 10 times 10 area. of the
radius
square.
of 5.
What people freak out is they don't know how to find the area of each circle.
Would it be 5 pi because that's the radius of the circle?
Well, the radius of this circle is 5 pi, but it's only a quarter of a circle.
But supposedly every is the same thing.
But realistically, it's 1/4, 2 quarters, 3 quarters, 4 quarters. It is one full circle with a radius of 5. So it'd be 100 minus 25 pi, which is like 23-ish. Cool? 25. Pretty close. Okay? So that was one that wrecked them. So I'll give you guys 15 minutes to play in the circles here. This one is graded.
Only ready.
1 through 18. That's your homework. This is your last graded assignment of the 9 weeks. Once I get all your grades in, I will wave my magic fingers and some grades will disappear, and then that will be your 9 weeks grade.
Are you still recording?
I have a question.
I will not do that. That is poor practice by a teacher. Oh, God.